Today we're going to learn our fourth method of solving quadratic equations, and that is using the quadratic formula. The quadratic formula will work with any quadratic equation, so this method will always work. The first thing you do in order to solve an equation using this method is you rewrite the equation into standard form. That is, you have the x squared term plus the x term plus your constant, and it needs to be equal to 0. So it needs to be in the form ax squared plus bx plus c equals 0. Then you just simply memorize what the quadratic formula is and substitute in the number values of a, b, and c into this formula. So the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Plugging that in will give you your two solutions. The number underneath the square root, that b squared minus 4ac, it tells you a lot about the quadratic equation. It's so important that it has its own name. It's called the discriminant. The discriminant symbol is the delta symbol. So delta is equal to that b squared minus 4ac, or the discriminant is equal to b squared minus 4ac. We'll learn in a little bit what this discriminant tells us, such as if the discriminant happens to be a positive value, then we know we're going to have two real solutions. If the discriminant happens to equal 0, there will only be one real solution to our quadratic equation. If our discriminant is equal to a negative value, there's no real solutions to our quadratic equation. Try using the quadratic formula to solve some equations. So first thing we need to do is write this into standard form by subtracting the 12 from each side. And now let's identify what our a, our b, and our c is. So remember, our quadratic formula is opposite of b plus or minus square root of b squared minus 4ac all over 2a. So looking at this, the number from the x squared is the a, the number from the x is the b, and the number from the number by itself is the c. Substituting those values in place of a, b, and c into our formula, we end up that x is equal to negative 1 plus or minus 7 divided by 2. So we're going to split that up. Negative 1 plus 7 is 6 divided by 2 is 3. And negative 1 minus 7 divided by 2 is equal to negative 4. So our solutions is x is equal to 3 or x is equal to negative 4. This is already in standard form, so I can start by disidentifying my a, b, and c and substituting into the formula. You'll notice as I'm working through this problem that we're going to be able to easily simplify it down. At this stage, we got negative 5 plus or minus the square root of 121 divided by 25. So 121 is our discriminant, which is a positive number, so we should get two real solutions in this problem. Let's see if we do. Yes, we got x equals 1/4 and x equals negative 2/3. Example 3, a would be the 1, b negative 4, c is 4. Then we substitute that into our quadratic formula above. Simplify the quadratic formula. X is equal to 4 plus or minus 0 over 2. Now when we do the plus or minus that, we know that 4 plus 0 and 4 minus 0 are the same thing, so we only have to do one of those problems. Get one real repeating solution, because if I did work out that 4 minus 0 divided by 2, I would end up with the same answer of 2. So it recurs twice, but we only say one real solution. Example 4, a is equal to 1, b is 2, and c is also 2. Plugging this into our quadratic equation formula and simplifying down, we end up with equal to a negative 2 plus or minus square root of negative 4 over 2. Now the first thing you want to notice is we've got negative underneath the square root. Now remember, we cannot have a negative underneath the square root. So at this point we know that this equation has no real solution. See for a minute what the discriminant tells us about a problem. If our discriminant equals 0, then we only have one real solution, and it's a repeated solution. And that solution we can find easily. We don't even have to work out through the entire quadratic formula. It is going to just be the opposite of b divided by 2a. If the discriminant is greater than 0, then we have the square root of a positive number, which is a real number. So we can say that there are two distinct real roots. Now these real roots could be either rational or irrational. If a, b, and c are rational numbers and the discriminant is a perfect square, then the equation has two rational roots that can be formed by factorization. So then we can also solve this equation two ways, either using quadratic formula or factorization. If the discriminant is less than 0, then we have negative underneath the square root, which does not exist. And so we do not have any real solutions to this type of problem. To summarize, when b squared minus 4ac is greater than 0, we will have two real roots to the problem. If a, b, c are rational numbers and the discriminant is a perfect square, then these two real roots will be rational. On the other hand, if the discriminant is not a perfect square, then there will be two real irrational roots. If the discriminant b squared minus 4ac is less than 0, there will be no real roots to the problem. If the discriminant is equal to 0, there will be one real root. Let's do a few examples of using the discriminant to determine how many real solutions we have. So in example 5, we know that our discriminant is going to be equal to b squared minus 4ac. And from this equation, we can see that a is equal to 3, b is equal to 10, and c is equal to 6. So plugging that into our discriminant formula and simplifying it down, we end up with a discriminant of 28. So since our discriminant is positive and it is not a perfect square, we know we have two real irrational roots, which means we have two real irrational solutions to the equation. Example 6, we see that a is equal to 4, b is equal to 1, c is equal to negative 6. Finding our discriminant by substituting it into b squared minus 4ac, we have a discriminant equal to 97. Since 97 is a real number and it's not a perfect square, we have two real irrational solutions to this problem. Example 7, a is equal to 4, b is equal to 4, and c is equal to 10. Plugging that into our discriminant equation and then simplifying it down, we find that our discriminant is equal to negative 144. Since the discriminant is negative, there's no real solutions to this problem. In example 8, a would be equal to 1, b is equal to negative 10, and c equals 25. Plugging that into our discriminant formula of b squared minus 4ac and simplifying it down, we end up that the discriminant is equal to 0. In this case, we only have one real solution to our equation. And since a, b, and c are rational numbers, the solution will be rational. Last but not least, in example number 9, we have a equal to 2, b is equal to 1, and c is equal to negative 10. Plugging that into our discriminant formula and simplifying it down, after substituting the values, we get that the discriminant is equal to 81, which is a perfect square. Therefore, this equation has two real rational solutions, since a, b, c is a rational number and the discriminant was a perfect square. You probably already noticed in this video, I've used the word solution and root interchangeably, and that's because they mean the same thing. Another word that means the same thing is the x-intercepts. So how many solutions a quadratic equation has represents graphically how many times that graph of the quadratic intersects the x-axis. Now notice our quadratic graphs tend to have this same U-shaped graph. So if we have two real rational roots, that's the same as saying we have two real solutions, and it's the same as saying we have two x-intercepts on the graph. Looking at the quadratic equation graphed in example 1, can you tell me if the discriminant is positive, negative, or equal to 0? So to do this, we will look at the x-intercepts. We have two x-intercepts for this graph. Since there are two x-intercepts, that tells us that our discriminant must be greater than 0. It must be a positive value. I ask you to look at this graph and tell me how many solutions it has. So since it has two x-intercepts, that means it has two real solutions. Or I might ask you, what are the solutions, the roots, or the x-intercepts of this graph? And those are all the same answer. Now looking at this, it appears to be about a -3 and about a 2. We'd have to zoom in and get a little bit closer to figure it out for sure. We're going to determine about the discriminant in example 2. So since it has no x-intercepts, we know that there is no real solutions to this problem. Therefore, the discriminant must be less than 0. And that means there's no x-intercepts to the graph. In example 3, we intersect the x-axis twice, so that means our discriminant must be positive. And there are 2 real solutions or 2 real roots, and those roots or x-intercepts are approximately -4 and 1. On example 4, we only intersect the x-axis once at the vertex of the equation, so that tells us our discriminant is equal to 0. There is 1 real solution, 1 x-intercept, and 1 root. And that appears to be approximately x equals 3.